All right, so in problem 1, we're trying to find the x-intercepts of each of these equations. So keep in mind for quadratic equations, in other words, when you have the graph of a parabola, so let's draw an example here. Let's just draw like a parabola like that. The x-intercepts are where it intersects the x-axis, and at these points, the y-coordinate will be always equal to 0. So we're going to call this x-intercept x1, comma 0, and this one will be x2, comma 0. So whenever you're trying to find the x-intercepts, remember to set the equation equal to 0, because, again, at any x-intercept, if I just draw like a random parabola like this with only one x-intercept, at this point, the y-coordinate is 0. So always keep that in mind. You always want to set the equation equal to 0 and then solve for x. Okay, so for example A, we have the product of these two binomials. So you really can just set each of these equal to 0, x plus 1 equal to 0, and then x minus 8 equal to 0, and then just solve each of these. So for the first one, we get x1 is -1, and our other x-intercept, adding 8, we'll get that x2 is equal to +8. So don't do more work than you have to, because again, when you multiply two numbers and you're going to get 0 out of it, that means either this has equal 0 or this has equal 0, or they're both equal to 0, because 0 times anything is 0. So then you can just set each of these equal to 0 and solve for x. All right, for b, we have x squared equals 144. So again, set this equation equal to 0. So take away 144 from each side, and we'll have x squared minus 144 equal to 0. And then this one you can just factor. You can just factor into x minus 12 times x plus 12 equal to 0. And again, you have the product of these two factors, and we can just set each of these equal to 0. And then just solve for x. So here, we're just going to add 12. We'll get one x-intercept equal to 12. And the other one, you subtract 12, you get our other x-intercept equal to -12. All right, for C, we still have the product of two factors. So another example, we just set x minus 2 equal to 0 and x plus 2 equal to 0. Adding 2, we'll get the first intercept, x1 equal to 2. Subtracting 2, we'll get the second x-intercept, x2 equal to -2. All right, the fourth example. Again, make sure to set this equal to 0. So we're going to take away 32 from each side. And we'll get x squared plus 14x minus 32 equal to 0. And then always try factoring first, especially if the numbers look, simple. But you can always do the quadratic formula. But remember, the factoring technique I use is we set up this x, and we use our a value, our b value, and our c value. On the sides, you're going to have a over something, or 1 over something, and 1 over something else. On the top, you have a times c, or 1 times -32. On the bottom, you have b, or 14. And then look for two numbers that multiply to -32 and add a 14. So multiplying to -32 and adds to 14, and that would be 16 and -2. Then we're going to use these four numbers in our factored form. So then this is the same as 1x plus 16 times 1x minus 2 equal to 0. And then again, now we have two simple factors that we can just break up and set equal to 0 and then solve. So we have x plus 16 equals 0, x minus 2 equal to 0. Solve each of these for x. We'll get our first x-intercept to be negative 16. Our second one will get to be 2. And here I'll just draw like what I use in my factoring technique. I call it the X games. B in the bottom, A times C at the top, A over something and A over something else. All right, next example, E. Okay, so now, again, don't get thrown off by this f of x or, y equal to something. Again, just replace that with a 0 because when you're trying to find x-intercepts, y is equal to 0. Now, in this case, so I don't waste your guys' time, you can't factor this. So when you can't factor, remember to use the quadratic formula. So the quadratic formula, and let me write down what the a, b, and c are. So a is equal to 1, because it's 1x squared. B is equal to negative 3. And then c equals negative 8. So the quadratic formula, negative b, so that's going to be positive 3 plus or minus the square root of b squared. So negative 3 squared minus 4 times a times c. All over 2 times a. I'm going to write it up here just in case you need a refresher. So negative b plus or minus the square root of b squared minus 4ac all over 2a. And then it really just comes down to simplifying this. Okay, so we got 3 plus or minus. That'll be 9 plus, because we have two negatives, plus 32 over 2. 3 plus minus the square root of 41 over 2. Let's approximate the square root of 41. We'll get about 6.4. Plus or minus 6.4. All over 2. So we got two answers here. We have one answer where you're going to add that 6.4. So we'll have x1 be where you're going to add 3 plus 6.4 all over 2. And we're going to have x2 be where you subtract 6.4. So x2 will be 3 minus 6.4 all over 2. All right, so let's simplifying this. We'll get, so we have 9.4 on top over 2. It'll give us 4.7. That'll be one of our intercepts. Here, take away 6.4. We'll get negative 3.4 over 2, giving us negative 1.7 for the second x-intercept. All right. Let me go ahead. Let me go straight let me do F actually next. But I'm going to need to do it on a different piece of paper because I ran out of space here. So give me a second to grab one. All right, so for F, we've got h of x is equal to x minus 5 squared plus 12. Okay, so we're still trying to find the x-intercepts. So set this equal to 0. And what we have to do is expand this. So we're going to have this be x minus 5 times x minus 5 plus 12. Don't be doing x squared minus 5 squared. That's one of my greatest fears for students. Just remember that you have to multiply the entire binomial by the binomial. So then make sure you distribute. So going step by step, x times minus 5, x squared minus 5x. Let me go minus 5x plus 25. Plus the 12 outside the parentheses. Simplifying, we get x squared minus 5x and minus the 5x, we get minus 10x. Plus 25 plus 12, so we get plus 37. So we're going to work with this and use the quadratic formula. So a will be equal to 1 because we have 1x squared. B will be equal to negative 10. And C will be equal to 37. So we're going to get x is equal to negative b, so positive 10 plus or minus the square root of b squared. So negative 10 squared minus 4 times a times c all over 2a, so all over 2 times 1. Now we got to just simplify this with 10 plus or minus the square root of 100 minus 4 times 37, so it's 74. So I think it's 148. All over 2. Working it out. 10 plus or minus 100 minus 148. We get the square root of negative 48. All over 2. Okay, so if you remember when you have the square root of a negative number, this is going to be an imaginary number or a complex number. So we take the square root of 48 to get an approximation, so about 6.93. So we're going to have 10 plus or minus 6.93. But since it's a negative number, it's going to be 6.93i. All over 2. So for reference, I is defined as the square root of negative 1. So remember this anytime you're taking the square root of a negative number. And then so your two answers are just going to be when you add 6.93i, and the other one's going to be when you subtract 6.93i. And you can divide. Let's simplify. Let's divide these both by 2. So then we're gonna get x is equal to 5 plus or minus dividing 6.93 by 2. We'll get about 3.46 I. And so we'll have one of our roots. X1 will be 5 plus 3.46 I. And then x2 will be when you subtract 3.46i. All right. All right, going back to G and H. So here we got some more quadratics where you have to find the x-intercepts or the roots. And feel free to jump ahead. So like try these on your own first, like pause the video, give them a shot, and then unpause it once you're ready and want to check your answer. But here I go. So again, we set this equal to 0. And we get 2x squared minus 10x plus 18. Using the quadratic formula again, we'll get a is equal to 2, b is equal to negative 10, and c is equal to 18. And so we'll get x equals negative b, so positive 10, plus or minus the square root of b squared. So negative 10 squared minus 4 times a times c all over 2a, so 2 times 2. Working this out step by step. 100 minus 8 times 18, so 80, so 145, I believe. Yeah, 144. So 100 minus 144 over 4. 10 plus or minus the square root of negative 44. So we're going to have another imaginary root. So we'll take an approximation to the square root of 44. We'll get about 6.63. And since it's a negative square root, or since we're taking the square root of a negative number, it'll be 6.63i about, approximately, all over 4. Let's divide everything by 4 so we can make it more simple to write down the two answers. So 10 divided by 4 will be 2.5 plus or minus 6.63 divided by 4 will be about 1.66. So plus or minus 1.66i. Then our two answers, one where you add 1.66i. And the other where you subtract 1.66i. Again, don't combine them with a 2.5. Leave them separated. There you go. All right, next one, h of x. So I'll do this on another piece of paper because I ran out of space again. We go over here. We got h of x is equal to x squared plus 3x plus 3. Quadratic formula again. A is 1, b is 3, and c is 3. The quadratic form is always guaranteed to work. You can always try factoring and other methods before that, but the quadratic form is always guaranteed to work. So my students usually just like using it. So then using the quadratic formula, we'll get x is negative b, so negative 3 plus or minus the square root of b squared. So 3 squared minus 4ac all over 2a. Negative 3 plus or minus the square root of 9 minus 12 over 2. Negative 3 plus or minus the square root of negative 3 over 2. So again, we have another square root of a negative number. So we're going to take the decimal approximation of the square root of 3, which is about 1.73. So we're going to have x is negative 3 plus or minus 1.73i all over 2. Dividing both of these by 2, we'll get x is, whoops, so we'll go, x is negative 1.5 plus minus 0.87-ish. Then one answer where you add this and the other where you subtract. So we'll have x1 will be negative 1.5 plus 0.87i. And x2 will be negative 1.5 minus 0.87i. All right. Whew. Okay, let's go back to the, we're done with page 1, which is probably one of the longest pages. Let's look at page 2. Okay, so here we're gonna basically practice and go over the coordinates of imaginary numbers, how we write them. In general, they have the form a plus bi. And just think of this as a being the x and b being the y. And then just plotted like, plotted like as you would plot xy on the xy plane. So then a plus bi is plotted like ab. The real axis is going to be the a, and then the imaginary axis is the b. It's imaginary because that's what you're multiplying by I, and a is just like your constant. So for example, point A here, assuming these are going by ones, you're going to have an a coordinate or a real coordinate of negative 3, and then b will be 1. So then this will be negative 3 plus 1i. Again, think of the negative 3 as the x and the 1 as the y. Point B, that's like negative 1 comma 3. So we're going to have negative 1 plus 3i. Point C, that's like negative 1, negative 3. So we're going to put negative 1 minus 3i. Point D, that's like 3, negative 1. So we're going to plot this as 3 minus 1i. Or we're going to write this as 3 minus 1i. These next ones, point E, Oh, so, okay, these ones were just plotting where we're given the coordinates. Let me put these in red. These next four were given the coordinates of these 4 points, and we got to plot them. So point E, we're told, is at 3 minus 3i. So 3 and negative 3. So 3 minus 3i will be like over here. Think of that as 3, negative 3. Point F is at negative 2 plus 4i, or think of this as negative 2, 4. So negative 2, 1, 2, 3, 4. So up here. Point G, this is like the same as 0 plus 1i. So think of this as like 0, comma 1. So it's going to be just right here. It's going to be up 1 unit. Point H, 1 minus 1i, or think of it as 1, negative 1. So 1, negative 1. And that's all there is to that. And problem 3, write each equation in standard form. Okay, so let's remember what standard form is. That's essentially when you have it, ax squared plus bx plus c, a, b, c. Make sure that the a is a coefficient of x squared, b is a coefficient of x, and c is your constant. So we don't have to solve anything. We just have to expand this. So f of x, remember that's just your y. So you can rewrite that as this. And what we're going to do is first multiply these two groups out. So we're going to have x times x, x times 4, 4x, negative 7 times x, minus 7x, negative 7 times 4, minus 28. Let's simplify the inside of the parentheses. So x squared just stays as x squared. 4x minus 7x, so minus 3x. And then minus 28. And then lastly, distribute the negative 2 to each of these. So negative 2 times x squared, negative 2x squared, negative 2 times negative 3x, so plus 6x, negative 2 times negative 28, plus 56. And there you go. And again, feel free to, you should probably try to first do these on your own. So like pause the video, try them, and then unpause it to see how you're doing. But here I go. Another one where we're going to distribute or factor the groups out first. So x times x, x times negative 11, negative 4 times x, negative 4 times negative 11, combining the negative 11x and the negative 4x. And then just distributing this negative symbol. Don't forget that. So then we'll get negative x squared plus 15x minus 44. All right, C. Okay, so here they're testing to make sure you know that x minus 5 squared is x minus 5 times x minus 5. Then you add the 7. So let's multiply these out. X times x, x squared, x times minus 5, minus 5x, minus 5 times x, minus 5x, minus 5 times minus 5 plus 25 in the parentheses and plus 7 outside. Combining like terms, we get x squared minus 10x plus 25, because we're gonna combine these two minus 5x's. Before you add the 7, multiply each of the terms inside here by -2. So we'll get -2x squared plus 20x minus 50 plus 7. Then you can add the 7 here. And so this minus 50 just becomes minus 50 plus 7, or minus 43. Your final form will be -2x squared plus 20x minus 43. All right, D looks kind of weird, which it is, but we just have this -3 on the left side of the equation, so we just add 3 to each side. Add it to the 6, so we're going to get then f of x equals negative times -2x minus 3 times x minus 5 plus 9. Because the 3 and the 6 add up. And then we can go ahead and just multiply this group out. So -2x times x will be -2x squared. -2x times -5 plus 10x. -3 times x minus 3x. -3 times -5 plus 15 plus the 9 outside. This negative gets distributed to each of these. Before that, though, let me combine these. 10x and minus 3x make a minus 7x. Or no, sorry, make a positive 7x. Then distributing the negative to each of those, we'll get negative times a negative. So we get positive 2x squared minus 7x minus 15 plus the 9 outside the parentheses. And then we'll just have 2x squared minus 7x minus 15 plus 9, which will just be minus 6. And there you go. All right, so in problem 4, we're going to go over factoring. And there's lots of different techniques for factoring. The one I usually teach my students, I call it the X games, or maybe I heard it called the X games, so I just call it X games as well, where you set up this, X or diamond, sometimes they call it. And with it, we're going to put A times C on top, B in the bottom, and then A over something and A over something else on the sides. And then underneath these A's, these fractions, as you're going to see, we look for two numbers that are going to multiply to equal A times C and add to be B. And this of course is when you have the form AX squared plus BX plus C. That's the general idea. There's a couple tips I'll show you with these examples, but that's the big idea. So let's look at the first problem. Okay, so here we have 6x squared plus 22x minus 8. To make your lives easier, try to always factor out something that goes into every term. So the greatest common factor. In this case, we can take out a 2. And so we're going to have 2 times 3x squared plus 11x minus 4. Then we're going to work with this as our x games. So let's let me write it. I'll put it right here. That's enough space. Okay, so a times c at the top. Our a is 3. Our c is -4. So 3 times -4, -12. B in the bottom. So 11 in the bottom. A over something on the sides. Then two numbers that multiply to -12 and add to 11. We're going to put those two numbers here. And that would be, what would that be? -12 and, or +12 and -1, right? +12 and -12. Yeah, +12 and -1. Now, make sure to reduce each of these fractions. So 3 over 12, we're going to reduce to 1 over 4. And we're going to use this. 3 over -1 is already reduced. So we're going to use those. And these four numbers, 1, 2, 3, 4, become your factors in this sense. So it's going to be 1x plus 4 times 3x minus 1. So 1x plus 4 times 3x minus 1. And that's going to be your factored form. Now, again, this is just a technique. There's different ways to go about this. Sometimes you get, some students get really good at just figuring the stuff out in their head, so they don't have to do this. But this is just a way I show my students because it's pretty much algorithmic and it'll virtually work for every quadratic. Every quadratic that can be factored. Okay, so let's do another one. So for B, we have A is 12, B is 5, and C is -3. So A times C on the top, so -36. B in the bottom, so 5 in the bottom. A over something, so 12 over something, and 12 over something on the sides. Two numbers that multiply to -36 and add to 5. And that would be 9 and -4. So -9, or 9 times -4, -36. 9 plus -4 is 5. And again, reduce these. So reduce 12 over -4 into 3 over -1. And 12 over 9 reduces to 4 over 3. So we're going to use these four numbers, and it doesn't matter the order. In other words, we can go 3x minus 1 times 4x plus 3, or 4x plus 3 times 3x minus 1. So this will equal to 4x plus 3 times 3x minus 1. And you can always check to make sure you factored it correctly, but I know that's correct, so I'm going to move on. All right, the next one, A, B, C. So A times C at the top, so -2 times 21, -42. B in the bottom, 11 in the bottom. A over something, so -2 over something on the sides. Two numbers that multiply to -42 and add to 11. Multiply to -42 and add to 11. That would be 14 and -3, yeah. All right, so then making these both positive, so we're going to use 2 over 3. Reducing this becomes -1 over 7. And so we're going to use these four numbers. And so this will be equal to -1x plus 7 times 2x plus 3. All right, one more. Okay, so here, for this one, let's factor out -2 out of everything. Again, to make our lives easier. So we're going to have -2 times 4x squared minus 21x plus 5. And then we're going to use this. This will be our A, B, and C. So A times C on top, so 4 times 5 at the top. B in the bottom, or -21 in the bottom. A over something, so 4 over something on the sides. Two numbers that multiply to 20 and add to -21. And that would be -20 and -1. Yeah, -20 times -1, +20. -20 plus -1, -21. And let's reduce these. This is already reduced. 4 over -20 becomes 1 over -5. And so we're going to use these 4 terms. So we're going to have -2 times 1x minus 5 times 4x minus 1. And there we go. All right, problem 5. Okay, now we're moving on to the imaginary numbers and how to use operations with them. For these ones, just when you're adding or subtracting, just think of I like it's a like term. So just like how you would add, like, let's say you have 2 plus 3x plus 5 minus 2x. Like terms are 2 and 5, so that would be 7. And 3x and minus 2x will give you 1x. So just treat the I like you would the x when you're adding and subtracting. So for example, the first one, we have 1 plus 5i. Taking away the parentheses, let's remember to distribute this negative. So we get -6, a minus and a minus, plus I, or plus 1i. Then we just combine the like terms. 1 and -6 make -5, 5i and 1i make a 6i. Next one, taking away the parentheses, we get 9 plus 4i minus 3 minus 2i. Combine the 9 and the -3, 6. The 4i and the -2i make 2i. So we get 6 plus 2i. For C, taking away the parentheses, 5 minus I, minus 11, plus 1i, or plus I. 5 minus 11 make -6. Minus 1i plus I make 0i, or just 0. So your final answer is just -6. Or -6, I mean. Okay, so now we're going to look at multiplication. So let's remember that I is defined to be the square root of -1. And so then when you have I squared, that's essentially I times I, which is the square root of -1 times the square root of -1, which is just going to be -1. So let's go through an example. So -5i times 3, -15i, -5i times -4i, plus 20i squared. Remember, I squared is -1, so this is like -15i plus 20 times -1, which is like -15i, minus 20, putting it in the a plus bi form. We're going to put the minus 20 first, followed by the minus 15i. Okay, now we have a binomial times a binomial, I guess. So just distributing 5 times 6, 30, 5 times 8i, 40i, negative 2i times 6, minus 12i, negative 2i times 8i, plus 16i squared. Drop into 30, 40i minus 12i, so plus 28i. 16i squared, that's 16 times negative 1. So this is 30 plus 28i minus 16. Or I mean, sorry, wait, that plus, oh, wow. I screwed up here. This would be a minus, wait, a minus 2i, plus 8i, that should be a minus I, minus 16i squared. So it should be minus 16 times a negative 1. And then that'll be a positive 16. Then we combine the 30 and the 16 to make 46, and then drop the 28i. And our final answer is 46 plus 28i. All right, for F, we got 3 times 3, 9. 3 times minus 2i, so minus 6i. 2i times 3 plus 6i. 2i times minus 2i minus 4i squared. These two terms cancel. So we have a 9 minus a 4 times a negative 1, because I squared again is negative 1. So this is just like 9 plus 4, which is just going to give us 13. All right, for the next one, we go 4 times 1, 4. 4 times minus 5i, minus 20i. I times 1, plus 1i. I times minus 5i, minus 5i squared. Drop the 4. Minus 20i plus I. Make a minus 19i. Minus 5i squared, or minus 5 times negative 1. So we get 4 minus 19i plus 5. 5 and 4 make 9. Drop the 19i. We get 9 minus 19i. And the last one here, negative 7 times 3, negative 21. Negative 7 times 9i, minus 63i. 4i times 3, 12i. And 4i times 9i, 36i squared. Okay, so drop into 21, or minus 21. Minus 63i plus 12i will make a minus 51i. Plus 36 times negative 1. This becomes negative 21 minus 51i minus 36. Negative 21 minus 36 makes minus 57. Drop the minus 51i, we get minus 57, or negative 57 minus 51i. And there we go. Okay, so I hope that helps. please give me any feedback, whether good or bad. Maybe I explained something too like confusingly, or maybe I explained something well. But just feedback is always helpful. In the next video, I'm gonna go over some examples of how we can graph quadratics. So I'm gonna go over simple ones and then some more complicated or ones with fractions. So be on the lookout for that. And of course, if you haven't subscribed yet, make sure you do. But all right, I'll see you guys then.